Let's consider this problem. Find the distance between the point -4, 3 and the line 5x minus 2y equals 1. What I think is a good idea here is to just go ahead and put this equation in slope-intercept form. It ends up being this. And then draw the sketch of that line, which is what you see here on the screen. Notice here I plotted -4, 3. So that's what I would do first. So put the line in slope-intercept form, graph it, and then plot the point so you have a visual aid. So we want to find the distance between this point and the line, and the shortest distance is going to be the perpendicular line. So it won't be this distance, it'll be this distance. So that perpendicular distance. So the perpendicular distance is the shortest, and that's what we want to find. So the strategy here is that we're going to find a point that's on this line and that would also be on the perpendicular line, and then we're going to use the distance formula to find the distance between those 2 points. I think that's super important, just understanding the strategy. So if you have to replay this video to understand what I've said so far, that's going to be more important than busting out trying to bust out the rest of the steps that we're going to do. There's a lot of steps. It's a difficult problem. So if you don't even understand the problem, there's really no sense moving forward. So replay if you have to, but understand what we're trying to do. Okay, once you do that, so since we have to find the perpendicular line that goes through this point and that touches this line, I'm going to find the perpendicular line to this equation, which is going to involve the negative reciprocal slope. So notice that I have used y equals -2/5 x because the negative reciprocal slope to 5/2 is -2/5. Negative reciprocal means that you flip the fraction and you change the sign. But it is going to have a different y-intercept, so I didn't put that in there. So y equals -2/5 x plus b. And then I'm using the point that they gave me to put in for x and y. And I'm going to do the calculation and find out that the b part of this is 7/5. So this is the equation that is perpendicular to the line and goes through the point that they gave. Make sure you understand these steps. So I put in -4 and 3, -4 for x, 3 for y, -2 times -4 is 8/5, and then you solve for b. So you subtract 8/5 from both sides. I didn't use the calculator, but you could, and you end up with the y-intercept of 7/5. There's my equation. One of the pitfalls of this kind of a problem is right here. So when you multiply a fraction by an integer, you only multiply the top number. So notice I didn't multiply the 5 there by -4. So that's pretty big. So there's the perpendicular line. So now I have the equation of the perpendicular line. So I have the equation that would be the line that goes here. The problem is I don't know what one point on both of the lines is. So that's what we're going to do next. So the way you do that is you set your two equations equal to one another. So where the two lines are equal to one another is going to be the x value at where they intersect. To solve this, since it has so many fractions, of course I could do it by hand if I'm a really good math student. Could use your calculator if that would be helpful. But what I think is the smartest thing to do is to realize that the least common denominator between 5 and 2 is 10. So if I multiply every term by 10, I get rid of the fractions and I get this. So 10 times -2 is -20. -20 divided by 5 is -4, so that's -4x. So forth and so on. So you're going to distribute that 10 to everything. It gets rid of all the fractions and gives you this equation, and if you get x on one side, you find out that x is 19/29. So that's the x value on the point that is perpendicular and on both lines. Okay, so the next thing you do is you take one of the equations that you started with. It doesn't matter which one, either the original equation or the perpendicular line equation, and you substitute this 19/29 in for x and solve that and find the y. So this is the point that is on both lines. This point, let me show you. is the point that is on this line and that line and perpendicular. So it's a point about right there. And if you have 2 points, you can find the distance between those 2 points, and that's your answer. So I used the calculator here. I did -2/5 times 19 over 29, and then I added 7/5. On my calculator, it gives you a mixed number, 1 and 4 over 29, which converts to 33 over 29 and is about 1.14. Now, it depends on your teacher on how soon you want to convert to decimals, but so some teachers would allow a decimal answer, some would not. I think most would allow a decimal answer. So you might even at this point just want to convert everything to decimals. That might be easier. I was torn because I wanted to show you both ways. So I did both. But this is the ordered pair we're talking about. So essentially, we've gotten this down. We're almost at the end. We really just need to find the distance between these 2 points. And like I say, you might just want to use decimals here. If you do, I would definitely use decimals rounded to the nearest hundredth or 2 decimal places. I wouldn't round it off too much, because that's going to introduce more error into your answer. So here's the distance formula. You need to be familiar with that. And this is x1, and this is y1, and this is x2, and this is y2. And I'm substituting those in here so it looks like that. And then I did this on the calculator, -4 minus 19 over 29. Got that answer, squared it, end up being this. At this point, I just converted to decimals. 3 minus 33 over 29, got that answer, squared it. That's about 3.47. Add those together, you get 25.14. Take the square root of that, it's about 5.01. That's the answer. Whew, that's a lengthy problem. If you've been doing this a while, then maybe that's enough for you to comprehend what we did. I would imagine it's going to be valuable to replay this video and to think through it. You might even want to slow it down. There is a way to slow down the player on YouTube. Or you might just want to try to work this from scratch and only play the parts that you need, but see if you can get that same answer. So if I back up here, let me show you what I'm talking about. So what we're saying is this distance is about 5.01. So that's what we're saying with this final answer. So there's a bunch of steps to this. There's so many things that you need to be able to do. Converting to slope-intercept form. You need to understand what it is we're trying to do. The perpendicular distance is going to be the shortest. You need to know how to find the line that is perpendicular to a line. So that's a skill in and of itself. If you're having trouble with that, there are some videos that just talk about that. The next thing is how to find a point that's on both lines, which is setting where the 2 lines intersect is the point that is the solution to them, and it's also a point that's common to both lines. So you could do that. So that's a skill in and of itself, setting each one of these equal to each other. And then finding the x and y value for that point. Excuse me. So this procedure gives you the x value, but then you have to turn around. This procedure up here gives you the x value. Setting them equal to each other gives you the x value. But then you have to take that and put it back into one of the equations. It doesn't really matter which one, but one of the equations, and that will give you the y value. So that's that. And then the distance between 2 points. So that is an equation and a difficulty in and of itself using the distance formula. Super good problem. It teaches a lot of math. There's a bunch going on here. Work on this and try to perfect the procedure.